Hello, you're in the mood for some trigonometry. I can sense it. Me too. And why wouldn't you be? Okay, why wouldn't you be? Today I'm going to talk about some addition formulae, give you some examples and show you how they're used. Okay, so these addition formulae, so called because you've got the sign of a plus b is sine a cos b plus cos a sine b, or sine a subtract b is equal to sine a cos b minus cos a sine b. Right, so that's how the plus minus works. The plus minus works here. With the cosine, you've just got to remember it's the other way around. So cos a plus b is cos a cos b minus sine a sine b, and cos a minus b is cos a cos b plus sine a sine b. And then with this one, tan a plus minus b, same as tan a plus minus tan b, all over. Make sure you get the signs correct. 1 minus plus tan a tan b. They're either given in the formula book or you've got to remember them. Okay, and that's basically it. It's applying them to different situations that you've got to be aware of. Now, it's unusual that you have to prove sine A and cos B, particularly in the A-level syllabus. It's not going to come up, okay? But you might have to demonstrate or show that tan A plus B is the same as tan A plus tan B over 1 minus tan A tan B. And that's the example I'm going to start off with, okay? It's to show that question, show that this is the same as that. Sometimes you get a bit of a hint. Sometimes you're told by considering the addition formula for sine A and cosine B. But if you're not, then you just got to know how to do it. So the way you'd start it off is you'd start off with the left-hand side, which is tan A plus B, and just write it as sine A plus B over cosine A plus B. And I'm hoping you're seeing where this is going. Maybe pause the video and have a go yourself and try and see if you can get to that, and then just play the video again when you think you're happy, or you just keep on watching. Okay. So this one here, so you've got to write down what that is. So look, I'm just going to go back to these. This is a reminder. Maybe you've got a screenshot of that, or you just note them down, okay, because I'm not going to refer to this screen particularly all the time. It's a case of having to remember them or sort of use your formula book if that's appropriate. But this one here, so you've got sine A cosine B, and it's plus cosine A sine B, all over, and then this one, cos A cos B, remember it's going to be minus sine A sine B, and we're very nearly there. Okay, we've just got to try and get that to that. This is a normal thing that happens with trigonometric equations when you've got fractions involved in particular, and with other entities where you've got a fraction and you've got to see how this has got to be changed into that. What I do is I try and focus on the simplest one, which is that term there, and try and see if I can get it to match that one. Okay. Now, the obvious thing I'm thinking of is if I just divide by cos A cos B, I'll get 1, and it works. I'm going to test it works with the others. Okay. If I divide this one by cos A cos B, do I get that? Yes, I do, because I get sine A over cos A and sine B over cos B, so I get that. And if I divide that by cos A cos B, well, the cos B will cancel, and left is sine A over cos A, which is tan A. And by a similar method, if I divide that by cos A cos B, the cos A's will cancel, and left is sine B over cos B, which is tan B. So that's my method. Okay. What I would suggest is you either write it down in the next step. Sorry, I'm trying to get rid of that. You write it down the next step, or you write it down like this: divide top and bottom by cos A cos B, and it's written like this, you see. So that means you're dividing all of the top by cos A cos B and all of the bottom by cos A cos B as well. Remember, that's just the same as dividing by 1, so you're not actually changing the value of the fraction at all. Or you just write it out like this. I'm going to do both. Sine A cos B gets a little bit, well, what's the word I'm looking for? There's a lot of stuff there, that's what I'm trying to say. Okay, I'm not going to say it gets complicated, because in A-level maths terms it's not, relatively, but it does, there's a lot going on. So that's just the numerator, you see. Remember, I'm dividing everything by cos A cos B. And then the denominator, yes, I'm going to write that as well, cos A cos B over cos A cos B this one, sine A, sine B over cos A, cos B. Oof, I'm there. I'm just going to put my equal sign in a more appropriate place there, because it's all of that, isn't it? Now, if you're in the exam, what you could do is this, and what I'd recommend you do is just, okay, a line through that. That's just going to be 1. The cos A there will cancel, and the cos B terms there will cancel. And then the next line, this is a bit annoying. Can I scroll down? Yes, I can scroll down a little bit, thank goodness, because I can fit it all on. And the next line, we'll just read as sine A over cos A, which is tan A, plus sine B over cos B, which is tan B, all over 1 minus, and sine A over cos A is tan A, and sine B over cos B is tan B, which is the right hand side, as required. I'll just scroll up, just check that. There it is, tan A plus tan B over 1 minus tan B. Okay, there we go. So that's, I'm not going to say a common examination question, it used to be, okay, but it's something that you might want to just practice and make sure you're able to do. Right. Next example, I like these ones, numerical ones. So if you type into your calculator sine 75 degrees, and your calculator in degrees mode, it will give you that. Okay. So the question is asking you to show that this is the same as that. Prove it. Okay. Demonstrate why this is actually the same as that without just typing it in. Okay. And the idea is you're supposed to use your addition formula. Obviously, use the sine A plus B, but you've got to decide how to split up the 75. And you're choosing values that you ought to be able to use from common knowledge or stuff that you've got saved up in your head, or you just need to be aware of. You can write down sine, cosine, tangent of angles like 45, 30 degrees quite simply using exact values. Okay. So what I suggest to you is the values that you know, apart from the obvious 0, 90, 180, 270 degrees, are the sine, cosine, tan of 30 degrees, 45 degrees, and 60 degrees. And usually this sort of question you can solve by having a combination of these. Now you could do sine of 90 minus 15 degrees, but 15 degrees is an awkward number. Okay, so I recommend you try and use a combination of these. Right? That's why I've chosen 45 and 30, because 45 plus 30 will make up 75 degrees. Had that been sine 15 degrees, I'd have gone for 45 minus 30. And same for cosine, 75 degrees, tan, 75 degrees. Right? So this is your general strategy for a question like that. Then it's a case of using the identity, writing out what that is. Remember to show that question, so you can't skip lines of working. So that would be sine 45 degrees, cosine 30 degrees, and then it's plus cosine 45 degrees, sine 30 degrees. That line is absolutely crucial, it's critical, you need that in. In fact, all of the work I'm doing for this question is critical, because it's a show that. With a show that, you've got to fill in every single step of working. Then you just write down what these are. Now you can actually cheat a little bit and use your calculator for this bit. The examiners aren't to know. I would rather you knew what this was, okay, root 2 over 2. But if you want to just use your calculator, that's absolutely fine. No one's going to notice, okay? But you've got to fill these in, okay? So cosine 30 degrees, that'll be root 3 over 2, and then plus cosine 45 degrees, it's root 2 over 2, and then sine 30 degrees, okay? If you're thinking, wow, he's doing that so quickly, well, so can you, if you memorise these, okay? That's how I did it, okay? Just over the years, I just committed them to memory, okay? And then you just simplify it, so root 2 times root 3 is root 6, and that's going to be over 4, and then this is going to be root 2 over 4, and just bear in mind what we're trying to do, we're trying to get that, so let's write it in the same form, root 6 plus root 2 all over 4. I didn't go for a left hand side, right hand side, so I'm just going to put as required, yeah, because that's the question we were asked to do. Okay, that's that. Got one more for you, this time an equation. Now you've got to be able to spot when to use which identity for an equation. Now because I've just started off with addition formulae, obviously in this video I'm going to use the addition formulae for this, but you've got to just know that that's one that you're going to use. Basically, if you know all the other formulae, look, there's no square terms there, so you're not going to use sine squared plus cos squared is 1, for example. There's no double angle formula because you've got no 2 theta or half theta or 3 theta or variations of theta. It's all the same angle, but you've got this in brackets. Remember, it doesn't work the same way as algebraic expansion, so you've got to think, well, all right, we're using this identity here, cos A minus B. All right. Maybe I'm just going to start by writing out what that identity is. So cos A, cos B, and that's going to be plus sine A, sine B. And what you've got to do is start with the left-hand side, okay, and just write down what you get. So 4 cosine and theta, so you just replace A with theta, so the cosine theta, cosine 30 degrees, and all of this in brackets, don't forget, because if you just multiply that by 4, for example, you have to multiply that by 4 and that by 4. So I'm just going to put that in brackets just to demonstrate that. Don't miss up the 4 because, yeah, in both terms, because you'll lose marks. And then what have I got? So plus sine theta, sine 30 degrees, close the bracket, and that's equal to 8 root 2 sine theta. We're not going to do anything with this yet because it's already in its simplest form. We're just going to see how that will come into play a little bit later on. My advice is whenever you get in an equation the cosine of an exact angle, work out what it is. Right? So cosine 30 degrees, that's going to be root 3 over 2. And then don't forget the 4 here, 4 sine theta, that's a horrible number 4, isn't it? I'm sorry. Sine 30 degrees, it's 1/2. You can work that out in the calculator if you wish. And again, equals 8 root 2 sine theta. Let's tidy it up a little bit. So 4 divided by 2 is 2 root 3. So 2 root 3 cosine theta plus 4 times half is 2. 2 sine theta is equal to 8 root 2 sine theta. Right, now we've got the equation in its simplest form. We've got to go ahead and solve it now. So what you've got to notice here is you've got 2 sine terms, 1 cosine term. We're done with all the identities. Put all the sines together, all the sine terms together. Okay. So what I'm going to do is, because that's a larger number, 8 root 2 is bigger than 2. I hope that's obvious. I'm going to put that onto that side. Normally when you're collecting terms, you do the large term subtract the smallest term, and I'll keep that positive. So I'm going to have 2 root 3 cosine theta is equal to, and I'm going to put that over there, and at the same time I'm going to factorise like this, sine theta, and then in brackets I've got 8 root 2 minus 2. Okay, you recognise this sort of situation, this sort of scenario? When you've got an equation with a cosine and a sine and no more terms, you can get a situation where you've got tan theta by dividing by cosine theta. So if I don't divide by cosine theta, you'll have tan theta. Okay, let's just scroll down a little bit more. Give myself a bit more space. So you're going to have tan theta. If you just do sine theta over cos theta, and then if you divide it by cosine theta, you're going to put this onto that side. So you have 2 root 3 over 8 root 2 minus 2 equals tan theta. All right. And we're very nearly there, because once you've got tan theta equals something, you can go ahead and work out what theta is. Okay, so like I said, cosine over to that side, sine over cosine is tan, and then this over that side, you've got this. Okay, that's an awkward number, but it's just, that's the number, isn't it? So if I just work out what that is, so 2, bear in mind, I'm not good at typing my calculator and talking at the same time. So it's 2 root 3, there we go. Of course, it's given to me as a surd in its simplest form, isn't it? It's given as 4 root 6 plus root 3 over 31, which of course it is for your rational denominator, but we don't care about that. We just want to know what that number is, so we can do the inverse tan of it. Okay? So having got that number, I'm going to do the inverse tan of that, and it gives me 20.4 degrees. It's 1 decimal place. And if you just check with the question itself, in degrees between 0 and 360, so I've just got one more solution to find, and I'm going to add 180 to that. So 180 plus that is 200.4 degrees. Okay? And that's it, all down to one decimal place. Okay? Well, hoping you found that very useful. Okay, thanks for tuning in, and look out for my other trigonometric videos. Okay, I aim to do some more identities, probably the double angle formula. Right, see you again.